Hello. In this video, I'm going to talk about a reciprocal of a linear function, right? A simple reciprocal of linear functions, where the reciprocals is talk about the linear functions. There are many types of reciprocal function. So it's either quadratic, cubic, sine, cos, tangent. But in this video, I'm going to talk about the linear function, okay? The basic of a reciprocal of a linear function. So the most basic concept of a reciprocal function will be 1 over x. 1 over x is the most simple one. So the output means the range, right? The output, and this is your input, right? Your output and input. So the input will decide the output. So this will be your domain. So the domain here, the x value here, you should not take all the value, right? There are value of x which cannot accept for reciprocal of linear function. For this case, x cannot be 0, right? As you know that a number cannot divide by 0. It's divided by 0, it will be meaningless, right? So when you said 0 divided by 2, you know it's 0. But you said 2 divided by 0, what is this, right? You don't know what is it represent. So now, if you said 1 over x, so the x cannot be 0, right? Cannot be 0. So this is a definition of a linear function, where the output can take any value except 0. Means that the denominator can take any value but except to be 0. So it's the same thing. So the graph for reciprocal function, the basic one will be look like this way, where you have learned during your secondary school. It will be, they won't touch the x-axis and y-axis when they're near to the positive infinity and negative infinity. When they're very far from the negative, the value getting more negative, the graph getting nearer to the axis but never intercept the axis. So this type of axis, we name it to be asymptote. Alright, this is the asymptote. So asymptote is the axis where the curve will approach to the curve when it's come to when x getting bigger or smaller. The curve will getting nearer, right? We're getting nearer to the axis. So this is called asymptotes. So there are two asymptotes here. So why would this happen? I will tell you more about about why the graph won't touch the x-axis during chapter 8 when I talk about limits, right? When I talk about limits. So now for you, just know, okay, the shape of the reciprocal function 1 over x will be in this way, right? So okay, very simple. You can see as the number of x getting bigger, they said 2, 3, 4, right? Of course, 1 over 2, 1 over 3, 1 over 4. As the number getting bigger, the whole thing will getting smaller, right? Can you see? It's getting smaller, right? This is the properties here. So how about fx equals to 1 over negative 1 over x? Same thing. The x shouldn't be 0, right? It can accept any value. It can accept all the value, but not 0, right? If you put 2, you will have negative 1 over 2 for fx. If you put 3, you have negative 1 over 3. You can put any value, but cannot be 0. So this graph is almost the same, but just now you know that this will be positive, right? Y above 0. So this is positive. This will be negative, the y value will be negative. But once you put negative, everything will be reflected about the x-axis. Just like the graph for square root. So it will turn out to be this way. This one will reflect it and go to the negative one. Because you multiply negative, this one, the positive one, the y value, the positive will become negative. And the negative one, you multiply with negative, you will become positive, right? So this is a basic graph for fx equals to 1 over x and fx equals to negative 1 over x. So simple is that if you know, okay, if I going to take the 1 over x, add with 2, right? What will happen to the graph? So let's see. Okay, 1 over x, you know that 1 over x, y and x, y and x. So I'm going to teach you how to read the domain and range later after you know the skill to draw the graph. So 1 over x, you know that 1 over x, the graph will be this way, right? So if we plus a 2 here, what happened, right? Plus a 2 here. So of course, everything when you plus 2, it was shifted vertically. Shifted vertically means that they will go up. If they minus, they will go down, vertically down. So now plus 2 means that the asymptote will change. The horizontal one, this one, the horizontal. Suppose it won't touch the x-axis. Because of this asymptote also move as well, because plus 2, it will become, this one is y equals to 0, right? And the asymptote here, y is equals to 0. So once you plus with 2, the asymptote will shift 2 above, means become y equals to 2. So I draw a dotted line here, and I put 2 here, right? Then I know the graph will be moving up. Supposed to be this one, but now moving up, it will become, if no longer touching the line y equals to 2, right? This is the line y equals to 2. They won't touch. And same thing happen for here. It will not touch the line y equals to 2, right? If you can see, comparison between this and this is that the graph have shifted above with 2. Alright, I give you another example. For example, if I have fx equals to negative 1 over x minus with 2, right? Minus with 2. So same thing happen. So you have graph x and y. So negative 1 over x. So you know the graph will be this one, right? If you minus 2 means the graph shifted, or very easy, the asymptote, the horizontal asymptote shifted below negative 2, okay? 2 units below. So means that it will become negative 2. And the graph supposed to be this way. Now they go down. So it will be lower down. Then this is y equals to negative 2, right? So they were going near this way. Everything shifted, go down. Alright? So for this type of case, you have to know the basic of the reciprocal function so that you can know what happened here. So I will go for more complicated problem in the next video. So before that, I need to tell you how to find the domain, right? The domain and range. Very easy. Okay, listen, this one very important, domain and range. So the domain f, range of f, is defined by, domain is referred to x-axis. You see, I already tell you, you can take any value of x. You can take any value of x, but cannot be 0. Means that you can write as negative infinity up to 0. You exclude the 0. Union 0 up to infinity. The meaning here is, I can accept any value, except 0. Okay, now? Or I can write as this way. All the real number except, I exclude the 0 as my input. Okay, now I shouldn't take 0. And for range, you will refer to the y-axis, right? You see the range. Means that the value of y for this line, it won't touch, right? So means y also cannot be 0. Y also cannot be 0. Because there is no number. You should understand the concept. Y cannot be 0. Why? Because y equals to 1 over x. 1 divided by any number won't become 0. Okay, now y cannot be 0. Alright, x cannot be 0. Y also cannot be 0. This is the special thing for reciprocal function. Because y, if y is 0, 1 over x equals to 0. This is no solution, you can't solve. 1 divided by any number also will not become 0. So means that you also cannot accept y equals to 0, right? So means, yeah, that's why you see they won't touch the x-axis, right? Because x-axis is y equals 0. That's why it's also the same. The negative infinity, this is for y. Also exclude the 0 and 0 to infinity. So, or you can write as real number, exclude the 0. Alright? So, okay, same thing here also. The domain will be the same. The domain is same thing. Alright? X also cannot be 0. So it will be the same. Right? The domain will be the same. And the range also will be the same. Right? The domain and range for this function will be the same. Alright? It will be the same because why? You see, they won't touch the x-axis also. But for this case, it's slightly different. Okay, slightly different. The domain, okay, the domain is still the same. 1 over x plus 2. X also cannot be 0, right? We look at this one, right? X cannot be 0. X can be any number but cannot be 0. So means that into 0 union 0 to infinity. Any value of x, but x cannot be 0, right? Can you see that? They won't touch the line x equals to 0. The y-axis is x equals to 0. They won't touch, right? They won't touch. So, and the range you can read from the graph, right? The range. This is the asymptote. This is the line y equals to 2. The graph won't touch the line y equals to 2. Means y cannot be 2. So if you see the graph moving up and they're disconnected here, they're discontinuous here, right? They have a breaking, the graph is breaking here. So they cannot accept y equals to 2. So from here I write negative infinity up to 2 union 2 up to infinity. Means I don't want the 2. Or you can write this one, exclude the 0. Or you can write all the real number except 2. This is how I read the domain and range from a reciprocal function. So, okay, I think I'm not going to tell you. I'm going to go for another video which is a bit slightly different from this reciprocal function. Alright, so see you.